Hi everyone, welcome to Algebra 1, the beginning of the year, section 02. This is our first section for the year. Remember, as we go through these notes and you have your note sheets, you need to fill these in order to get the credit. I'm looking for the information as well as the lesson summary and the practice problem that are at the end of the sheet. So keep that in mind. I try to say things extra, or I do say things extra besides what I actually talk about, or besides what I actually write. I got this. And it is worthwhile listening to because I do give you hints or tips or whatever. So here we go. Let's talk about this. The beginning of any chapter, any year, any semester, anything in math comes down to a lot of terminology. And so we're going to talk about numbers, sets of numbers. Here's all the numbers that we're going to be dealing with this year. They're real numbers. There's a whole nother set of numbers that are called imaginary, and we're not going to worry about those quite yet. But we need to talk about our real numbers. So if you notice on this diagram over here, these real numbers are all of them. Everything inside those two sets of boxes there are real numbers. So I'm going to actually do this a little bit out of order. So real numbers are all of the above numbers that we're going to talk about in a second, and they break into rational and irrational numbers. So rational and irrational. Well, irrationals are the easier ones to talk about. If we're going to talk about these two types of numbers, let's get irrationals taken care of first. So over on this side box, the big one that's got nothing else. Sorry about that, I had technical difficulty. Nothing else going on. This whole section over here is irrational. Notice it's all by itself because once we look at these types of numbers, there's no other way to break them down. They're decimals that will never end and never repeat. Never end and never repeat. Rational numbers, on the other hand, this whole other section over here are rationals. So you either got rationals or irrationals. Irrationals are what they are. Rationals, notice we've got some circles within here. So rational numbers are decimals that either end or repeat. Remember, we can turn fractions into decimals to figure this out. So for example, if I gave you 1/2, what's 1/2 as a decimal? Everybody better know this one. 0.5, right? That ends, it terminates. It doesn't repeat, it just is a 0.5 and doesn't keep going. If we're talking about an irrational number, we might have 3.1415976384185 ... I'm going to use those ... dots a lot because that tells us that they do not end and do not repeat. Repeat, we have a bar. So if I asked you what is 1/3 as a decimal, what would you tell me? Everybody knows how to figure that out in your calculator, right? You go to your calculator, you do 1 divided by 3 and hit the equal sign, and it turns it into a decimal for you. So if you go to your calculator, that's going to be 0.33333333333. Nobody wants to write all those threes, so we put a repeat bar above that. That tells us that the 3 is the thing that keeps repeating. Here's the thing, though. A rational number, what about like 7? 7, it's not a decimal, but it's a whole number, right? Does it end? Does it repeat? It doesn't repeat, but it does end. So 7 is an example of a rational number, so that nice, neat whole number. So working our way up, integers are all positive and negative whole numbers. So whole numbers are not decimals or not parts of numbers. So when we look at our circles up here, this is going to be integers. Some people pronounce that really weird, but it's called integers. So integers are a type of rational. So in this big box up here, this part that I'm going to highlight, this out here are all those fractions that either repeat or terminate. This is fraction land out here. Inside the boxes or inside the circles are where we have whole numbers. So positive and negative whole numbers. Whole numbers come next, and these are any whole number. It's hard to define a number or word with the same word, right? But any whole number, so no part of a number, from 0 to infinity. So these guys are wholes. And 0 from infinity means, can we have any negatives in there? So these are positive including 0. And natural numbers, or counting numbers, is how I always think of them. And this is when you first learn counting. Remember when you're in kindergarten, or when you do 1, 2, buckle my shoe, 3, 4, shut the door, 5, 6, pick up sticks. These are all whole numbers from 1 to infinity. If we're going to put, and so I better put those guys on here, here's our natural or counting. So notice natural aren't all of the rational numbers, they're just that little box. Whole numbers are all the naturals plus a little bit extra. Integers are all the whole and natural plus some extra. And rationals are all those integers plus the extra fractions and decimals. If we were going to look at a number line for, say, natural numbers, there's no room up there, so I'll just, so if we call these natural numbers, so here's my number line, 0, 1, 2, 3, -1, -2, -3. Well, if natural numbers are all the, or counting numbers, are all the whole numbers from 1 to infinity, what we would do to mark that on a number line is we would mark 1. Are we allowed to have any decimals in between 1 and 2? No, right? So we'll just put a closed circle on 2, 3. Now, if we don't want to keep putting dots on every single whole number to infinity, which would never end, what we do is we shade in the arrow, and that shows that the same pattern is going to go, which means it's going to go from 4, 5, 6, 7, 8, all the whole numbers. We'll talk about sets too. All right, so let's talk about what set of numbers these guys belong to. So if we've got a 1/6, if you go to your calculator, because we talked about what does that look like as a decimal, 1/6 comes out to 0.166666, and probably try it on your calculator, there's a 7 at the end. But there's a 7 at the end because your calculator rounded for you. So really what this is a 0.16 repeating. What kind of number is it when it repeats? Rational or irrational? So we've got ourselves a rational number. Let's talk about -9/2. Actually, no, let's go right down to the 8. I do skip a lot of the practice problems. We use those for warm-ups or to go back and practice with later in class when we talk about these things. So 8. What kind of number is 8? Is it rational or irrational? Remember, irrational is when it never repeats and never terminates. So this is definitely rational because it's just a number. Is it, now go up the line, go through those circles, is it an integer? Is it a positive or negative whole number? It sure is. Is it a whole number? 8 is a whole number. Is it a counting or natural number? Sure is, from 1 to infinity. So that has 4 categories or 4 sets of numbers that 8 belongs to. We'll talk about the other 2 in class. Let's talk about square roots here. We should probably address this. So a square root is one of 2 equal factors of a number. One of 2 equal factors of a number. So for example, 5 times 5, those 2 factors are equal, is 25, which means the square root of 25 is 5. Perfect square is a number that has a rational square root, like 25 is a perfect square. What's another perfect square? How about a 36, right? Because what is the square root of 36? What times itself will give you 36? 6. What's another example? How about 81, right? Because what times itself will give you an 81? So we know that's a perfect square. Not an example. How about 10? 10 is not a perfect square, right? Because, I don't know, nothing times itself gives you a 10. And when we could probably figure out some irrational number times itself that would give you 10. But remember, this has to have a rational whole number square root. The first 12 perfect squares, are you ready? So here's our x, here's our x squared. So if I said that x is 1, what is 1 squared? Let me just, I'm going to do this. 11, 12, there we go. So 1 squared is 1. So 1 is a perfect square. What's 2 squared? 3 squared. So 9 is a perfect square because 3 times 3 is 9. Fill the rest of those guys in. I don't think we need to do that. That's just calculator work, or hopefully you know your times tables because we're going to use them a lot. So another one of these, name the set or set of numbers to which each number belongs, because now we got some crazy numbers. Go to your calculator, please. Try the square root of 17. If I have my math facts straight, it's going to be like 4.1 blah, 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 something. I don't even know. Notice how I use those 3 dots. That tells me that it goes on. There is no pattern. There is no repetition. There is no end, which means the square root of 17 is an irrational number. How about straight below, example C, 7/9? Go to your calculator because we always think about these in terms of fractions, right? So 7/9 is, type it in your calculator, 7 divided by 9. And if I'm remembering right, that's going to be 0.777777778. Why is the 8 at the end? Because your calculator rounded for you. So if I'm thinking right, that's a 0.7 repeating. Is it a rational or an irrational number that repeats? Rational number. Now, since we're on that rational side of the box, where we've got the circles within it, does 0.7 repeating, is it fall into integers, whole numbers, or natural numbers? No, it doesn't, right? Because it's only those decimals and fractions that are in that square part, but not in the circles. How about a 121 square root of? Everybody knows the square root sign, right? Square root of 121. Is 121 a perfect square? Why, yes, it is. So 11. So you go ahead and name the sets of numbers. How about a negative square root of 36? I like this one because this negative we have to just bring over onto our answer. Do the square root of 36 on your calculator, you should get a 6. Is -6 a rational or an irrational number? Well, that guy is rational, right? It terminates, it's just a -6. Is it an integer, a positive or negative whole number? Sure is. Is it a whole number? From 0 to infinity. That negative makes it not whole, so it's just rational and an integer. So here are some things to think about, and I think we probably will talk about these maybe for the warm-up. I would like you to think about an integer that's a whole number, an integer that is not a whole number, and a natural number. Give a number that fits those descriptions. So, lesson summary. Remember, I am looking for these to be completed. Please tell me in this box, don't write out the question, just write the answer. What's the difference between a rational and irrational number? I'm never going to give you some kind of crazy question. That's going back to that beginning and looking at what's the difference. You could define them both. You could say this has this and this has this. What's the difference between rational and irrational? And 2 practice problems. They're not that difficult. The first one, give me an example of an irrational number. Ooh, we should have done a certain example, like an example. Oh, I can't even find it. There's one in there. See what you can come up with. I know that you've heard of this before. Give an example of a whole number that is not rational. Hint. there may not be an answer for one of these two questions. So make sure you note that. Don't just leave it blank, because if you leave it blank, I think that you didn't do it. So that's the end of lesson 02. If you've got questions, bring them to class. We'll talk about this before we get going on work, and make sure you watch it because that's important. So we'll see you guys next time.